Hello students, welcome to Sorosur classes. For detailed information about our classes, you can visit our website, that is www.sorosurclasses.com, and for other doubts and queries you can call us or WhatsApp us at this number 9836793076. You can even like our videos and subscribe our channel for further more videos. Today we are solving some questions on rotation, and our first question is a stone of mass m. So the mass of the stone is given, and that is m, tied to the end of a steering, is whirled around in a horizontal circle. It is also given to neglect the force due to gravity. The length of the steering is reduced gradually, keeping the angular momentum of the stone about the center of the circle constant. Then the tension in the steering is given by T is equals to A r to the power n. T is equals to, it is given that T is A r to the power n, where A is a constant, r is the instantaneous radius of the circle, then n is, we have to find the value of n here. So now let's proceed to the solution. We can write it as m vr is equals to k, that is given, and it is a constant. Now from this we can write it as v is equals to k by m r. Now we can write T is equals to mv square by r, that is equals to m by r into k by mr whole square, that is equals to k square by m into 1 by r cube. So from this we can write that T is equals to A r to the power minus 3, where A is equals to k square by m. Hence we can write that n is equals to minus 3. So here n is equals to minus 3, and this is our answer. Now let's proceed to the next question, and the question is, it's a very important question and it's simple, so easy. So the question is, a smooth uniform rod of length L, the length of the rod is given, and that is L, and mass is also given, that is m, has two identical heads of negligible size, each of mass m, which can slide freely along the road. Initially, the two beds are at the center of the road, and the system is rotating with an angular velocity, that is omega 0, about an axis perpendicular to the rod and passing through the midpoint of the rod. This is given in the figure below. There are no external forces, it is also given, and when the beads reaches the ends of the rod, the angular velocity of the system is, we have to find this angular velocity, and this is the diagram given. So we can write that I1 omega 1 is equals to I2 omega 2. From this we can rewrite it as omega 2 that we have to find is equals to I1 by I2 into omega 1, that is equals to, putting the dimensions, we can rewrite it as m L square divided by 12 whole divided by m L square divided by 12 plus 2m into L by 2 whole square into omega 0. Now from this we can write that m L square divided by m L square plus 6 small l L square into omega 0, that is m by m plus 6m into omega 0. So here our angular velocity of the system is m by m plus 6m into omega 0. Now this is our next question, and the question is, a thin uniform circular disk of mass m and radius r is rotating in a horizontal plane about an axis passing through its center and perpendicular to its plane with an angular velocity that is omega. Another disk of the same dimensions but of mass m by 4, sorry, it's because of misprinting. So it's plane with an angular velocity that is omega, and another disk of the same dimension but of mass m by 4 is placed gently on the first disk coaxially. The angular velocity of the system now is 2 omega by root over 5. So now let's proceed to the solution. We can rewrite it as I1 omega 1 is equals to I2 omega 2. Now from this we can write omega 2 is equals to I1 by I2 into omega 1, and putting the dimensions we can write it as mr square by 2 divided by m r square by 2 plus m by 4 into r square by 2 into omega, that is equals to 4 by 5 omega. So here the answer is, and the angular velocity, the final angular velocity is 4 by 5 omega.